Okay guys, I'm going to go over a couple of the Chapter 4 test review questions that I think we would have the most trouble with. The first three I want to look at those graphing ones, because I know we kind of struggle a little bit on how to at least start to graph them, right? So let's go over first, number one. This, when you look at that quadratic equation, okay, that's in standard form. So this is standard form. This was in section 1, okay? And in that section, when we graphed in standard form, we needed first an axis of symmetry, okay? And we got that axis of symmetry by the little formula, negative b over 2a, and it was supposed to equal our x value, okay? So I need to first pick out what a and b is, right? So a in this case is 1/3 and b is 2. So here's a and b. And I'm just going to plug those into that little formula. So negative b, or negative 2 over 2 times a, or 1/3. Okay? If you do that in your calculator, right, negative 2 divided by 2 times 1/3 is actually negative 3. So you have to be careful on that one, okay? We also need a vertex, so that was the first thing we needed. The second thing we need is a vertex, okay? And remember, a vertex is just a point, x, y, where x goes first. Well, we just figured that out, right? That was negative 3. But to get the y, though, I'm going to need to plug in my x value and see what I get back for y. So if I do that, I'm plugging in negative 3 in for x. And see when I get back for y. So when you guys do that in the calculator, you should get back negative 4. Okay, so that's my y value, negative 4. And there's my vertex, negative 3, negative 4. That was the second thing we needed. Okay, and the last thing we need is the y-intercept for standard form. Okay, so this is our third and final piece. Okay, this is always going to look like 0 c, or whatever that constant is, tacked on the end in the quadratic equation, okay? And it's 0 for an x value because that's just where we're crossing the y-axis, which is always going to be an x value of 0, okay? So in this case, my constant tacked on the end is negative 1, so it's 0, negative 1, okay, is my y-intercept. And if we actually go graph this, I can graph my vertex, negative 3, negative 4. And I can graph that axis of symmetry, the dotted line that makes my parabola or curve symmetrical. Okay, and I'll kind of highlight that better, that point. So there's that vertex point. And 0, negative 1 is my y-intercept crossing the y. And the only thing I have left to do is reflect that to the other side. So it was 1, 2, 3 units away from my axis of symmetry. So I'm going to go 1, 2, 3 more to the left of my axis of symmetry, and that will allow me enough points to where I can connect them with my smooth parabola curve. Okay, so I need at least 3 points in order to graph that parabola. So that axis of symmetry is really helpful to reflect points over to the other side, so you can help actually graph it. Okay, so again, you need 3 pieces of info when you go and graph in standard form. Okay, we need the axis of symmetry. The second thing we need is a vertex. And the third thing we need is the y-intercept. Okay, that next one, in number 2, this one's vertex form. Okay, this was in section 2. So this is vertex form. With vertex form, we don't use that little formula, negative b over 2a anymore. Okay, we already know the vertex just by looking at the equation itself, okay? So that's the first thing we need, is a vertex for this kind of form. Well, it's always going to come from that, or whatever inside the parentheses. Okay, you're always going to flip the sign on it. So right now it's a negative 2. It's going to become a positive 2. That's my x value. And then the y value, so that was the x. the y value is always tacked on the end. In this case, it is 6. So here's my vertex, 2, 6. And I can graph that. The axis of symmetry is running down through that x value. That's 2. Okay. So I can again draw that. Axis of symmetry dotted line. But I can't really get anything else out of my quadratic equation, okay, just by looking at it. So now, with vertex form, what I'm going to have to do is figure out 2 points, 2 other points to put on there, okay? And how we're going to do this is we're going to pick values close to the x value that we got. In this case is close to 2, because that's my x value right now. So I'm going to pick like maybe 1 and 3 for x values. Okay, and how we're going to get that y value back is just by plugging those x values into the original equation. Okay, so if I do that, if I plug 1 in first, 1 minus 2 squared plus 6. Okay, that should give you 7. So 7 is my y value there. And if I plug 3 in, that should also give you 7. Okay, because when you graph these, 1, 7, which will be off the graph a little bit. Oops, there we go. And the other one is 3, 7. And when you look at them, they are symmetric, those 2 points. That can help me draw my parabola, okay? So with vertex form, you also need 3 things. You need a vertex, you need an axis of symmetry, and 2 points, 2 additional points to help you draw that parabola, okay? So that was vertex form. The last one we're going to look at here, graphing-wise, is number 3. This one's actually vertex form. Or not vertex form, sorry, intercept form. With intercept form, we have 2 x-intercepts. So that's the first thing I want, the x-intercepts. I'll abbreviate it like that. And that comes from what's inside my parentheses. But sometimes you guys forget to flip the signs on these too. So if you see a set of parentheses, know that you need to flip the sign on them, okay? So that first one should be 1, 0. And the other one should be -4, 0. Okay? And the 0 for the y value, because at the x-intercepts, your y value is 0. So that's our x-intercepts. That's 2 pieces we already got. Now we need a vertex. Okay? And for this one, intercept form, all we need to do is add together our x-intercepts, so 1 plus -4, and cut it in half. We're trying to find the middle x value with these. So 1 plus -4 divided by 2 is just -3 halves, or you could think of it as -1.5. Okay, so my vertex starts out with -1.5. I'm just going to keep it as a decimal. And how, again, I'm going to get that y value is by just plugging that x value back in to the original equation. So I'm going to do that here. Okay, and when you do that, you should get back out 25 or 4 or 6.25 or 6 1/4. I'm just going to leave it as a decimal again because it's kind of easier to graph. So -1.5 and 6.25. So let me try to graph that first. -1.5 and then 6 1/4. Probably up in here somewhere. Okay, and then my x-intercepts 1, 0 and -4, 0. And lastly, I'm just going to connect them because it's all symmetrical here. And it should look a very smooth and continuous curve. Mine does not look like that right now. Okay. And also throw in the axis of symmetry. Okay. Running down through -1.5 to help make that parabola symmetrical. Okay, so you guys need to know these 3 different kinds of forms to graph a parabola or graph quadratic equations. Okay. The other one on the other side here is this modeling equation here. So we're actually going to use this. There's a typo here. Not there. But this should say through. Maybe. There we go. Through 6. Questions 5 through 6. Okay, so a baker has modeled the monthly operating costs for making wedding cakes by the function shown here, where y is the total cost. That's important. And x is the number of cakes. That's also important. Number 4 says, okay, find the vertex and the axis of symmetry. Okay, so first I'm going to start with the axis of symmetry. If I look at my equation here, that's in standard form. Okay, that's important. So in order to get standard form's axis of symmetry, that was the little formula for x, negative b over 2a, right? And if I plug in what I know for a and b there, it's going to become positive 14 since my b was originally negative, over 2 times a quarter, or 0.25. And if you simplify that, that is 28. So that's our x value as well in the vertex, 28. Okay, how I get the y value again is, well, I'm going to take that x value and I'm going to plug it back in.
Attention any teachers that are still in the building. If you have any mailing out to students, we will please like them in the office by 1 o'clock. By 1 o'clock, please, so we can get our mailing done. Thanks.
Sorry, guys. So if I want y, I'm going to plug that back in. So 0.25, and then I'm plugging in 28 for my x value, minus 14 times 28, plus 245. And when you guys do that, plug that in the calculator, you get 49 back. So that's the y value, 49. So there's my vertex, and there's my axis of symmetry. Number 5 wants to know, well, what's the minimum cost? Well, what did minimum cost mean? Okay, well, total cost was equal to the y value, right? And we have a minimum at our vertex. So I'm going to use that vertex, 28, 49. And what did 49 represent? Well, that meant a total cost. So my minimum cost is $49, since y value meant total minimum cost. Okay, then in number 6, how many cakes should be prepared each month to yield the minimum cost? Well, again, that came from our vertex here. So 49 meant the total cost, or total minimum cost, and the x value here means the minimum number of cakes. Okay, so 28 cakes would be that answer if I could spell. There we go. So 28 cakes. Number 7 is exactly like 5, or no, number 4. Okay, you're picking out, does it have a minimum or maximum value? And then find that minimum or maximum value. Okay, over here with 8 and 9, you will need the x method. Okay, number 8, remember, you take 1 times negative 8, and that'll go up top. But in number 9, okay, your a is not 1 anymore, it's 12. So 12 times negative 11, that is negative 132. And in the bottom is just going to be 1, because that's my b value right now. So you're trying to find factors of negative 132 that can add to 1. But the actual factors you already have, okay? Because 12 minus 11 is 1, but when you multiply them, they do make regular old negative 132, okay? But on top, remember, I'm not just putting an x, I'm putting whatever my a value was, which was 12, and attaching the x. Then I gotta see, can these reduce? Well, on the left-hand side, yeah, 12 can go into both of those. So I'm left with 1x over 1. And then the other side, 12 and 11 can't reduce down. So my factors here, x plus 1 and 12x minus 11, okay? I don't have to split and solve because it wasn't originally set equal to 0, so I'm okay right there. And also, first off, I checked to see, well, could I divide anything out? Okay, so like for example, if I had 3x squared plus 6x plus 9, well, I could divide all those by 3 first, right? Because 3 can go into all 3 of those coefficients. So make sure to check and see before you even go to try. Make sure you can not divide out anything before you start. All right, and number 10 is pretty popular here, okay? We have this wilderness park. Don't be afraid to actually draw it, right? It's approximately 2 mile wide by 6 mile wide. And the project's underway to make it 5 times as big, okay? So, if I try to draw that one, it's basically I'm adding X amount to the width and X amount to the length. And it's supposed to be 5 times its current area. So in the original area, it'd be 2 times 6, right? Because area is length times width. So in this one, I had 5 times 2 times 6, or 5 times the current area there. So first thing we need to do is write and solve an equation for that new project, okay? Well, if I go to do that, area is length times width, right? So I'm going to do my width, let's say, x plus 2, and I can rewrite it like this if I wanted to, times x plus 6, and it's supposed to equal 5 times 2 times 6, right? Well, that's just 60. I'll just simplify that. Now, that is our equation. That's the first part, but I still got to solve for whatever the heck x is and try to find the new dimensions of this park. Excuse me. So, now I need to FOIL. So when I go to FOIL, that is x squared plus 6x plus 2x plus 12 equals 60. And I'm going to combine some like terms. And then I'm going to move the 60 to the other side by subtracting it. So I'm left with x squared plus 8x minus 48 equals 0. Okay, and now you can factor this stuff with the x method. Okay, so if I try to do that real quick, well, my a value, which is 1, times negative 48 is negative 48. And then my b in this case is 8. And if I try to think of factors of negative 48, I know 1 and 48, right? And let's see, 4 and 12. And if I check yet to make 8, yeah, 4 and 12 can make 8. Okay, if I do negative 4 and positive 12, right? And then I'm going to put regular old x on top since my a was 1. So here's my factors that break this apart. So x minus 4 and x plus 12 equals 0. And now I need to do is just split them apart and solve. So x will be 4 here, and x will be negative 12. And if I think about negative stuff, right, can I plug a negative value back in for a side length and get another negative side length? No, area can't be negative, so I'm going to reject this one. Okay, because I can't have negative area. So my only answer here is 4. Okay, but I'm still not quite done. I need to find the new dimensions, and that's coming from up here. So my new dimension of the new project here is, well, on the width, 4 plus 2 is 6, so that's 6 mile by 6 plus 4 here for the length, 10 mile. So I needed 3 pieces of info for this problem. I needed that equation that I boxed in red. I needed the x value, which I boxed in blue. Okay? And then when I boxed in green here, the new dimensions, because I needed the new dimensions of that project. All right, 11 and 12 are writing it in intercept form. That's just factoring again. Okay? And 13, 14, 15. 13, you're just simplifying. 14, 15, you're solving again. You can use any method on number 15. I forgot to put that in there, but I think you guys could figure it out. 16 is another complex number, but remember, you need to multiply by the conjugate, which is just the opposite sign of what's ever underneath. And you're multiplying that top and the bottom, so you're going to have to double FOIL that one out. All right. Absolute value for that, remember, you're just taking the big square root of the first number squared plus the second number squared and leaving I out of it. Okay, leave I out. 18 and 19 are the same exact way, complete the square. But if you notice on number 19, you have coefficients 3, 36, and 42. All of those can be divided by 3. So remember, you want your A value to be 1 before you even start completing the square. So that's very important on number 19. Number 20, you're going to have to rewrite it a little bit so that it equals 0 before you actually start the process of complete the square. 21 and 22. The discriminant, remember, that's a little formula. It's part of the quadratic formula, but it's b squared minus 4ac. Does not include the square root. Okay, some of you guys want to still put the square root on top of that. No, it's what's underneath the square root. That's the discriminant formula. Okay, same thing on 22. You're going to use the same exact thing. And then 23, 24, 25, that's using the quadratic formula, and you guys were doing really, really good with that. I feel pretty confident that you guys can handle that. Okay. If there's any other ones that you guys want me to help you out with or work out for you, see if you're doing it right, let me know, okay? I will be posting the solutions later, probably tomorrow, Saturday morning for you guys. You also can use this video, okay? I will be posting the actual Chapter 4 test probably Sunday night or Sunday around noon. Just kind of depends when I get to that, okay? All right, guys, thank you. Email me if you have any more questions.